So this is gonna be probably the last thing for today, I guess, because I kind of made a lot of videos. So we have frictional forces, and all they are okay. Well, let's go over static friction. Well, static friction prevents motion between surfaces. I mean, there's technically only one type of friction in this lesson, but there's a little bit more nuance here. So I'll explain this real quick. So also that's mu, by the way. It's not music or anything. That's this U letter right here, but I have it down here just in case you guys don't know what mu is. So let's take an object here that's just sitting at rest. It's technically is exerting a normal force, but notice that there. Hold on, let me just. So let's take this box here. And remember what the normal force is. It's a downwards object acting on a sideways object, or perpendicular forces. So this is pushing down, this is pushing up. Not perpendicular forces. A perpendicular force. A force perpendicular to the object's orientation. Yes, that's the most best way I could explain it. So this this normal force is acting downwards. But note that there's no plus force or minus force, because we're not applying any force to it. It's just an object sitting down, getting pulled down by gravity. Now, what happens if we apply a small bit of force? Let's say a little kid throws a ball at it, and the ball hits and transfers its force to the object. Well, what will happen is the object will maybe slightly move a little bit, depending on the mass. Remember, force equals mass times acceleration. So, depends how much it'll move. Let's say it moves just like 1 inch, so like this much, this interval right here. Well, note that what is stopping it? It's friction. But friction doesn't act until a force is acted upon it. So the friction isn't making an object move. That's what static friction is. Static friction is a latent friction, or friction that doesn't do anything until another opposing friction or another opposing force acts on it. So in simple terms, static friction is the force that is applied when another force is applied, pretty much. So nothing is happening to this box until, let's say, that a construction worker, wants to push this box. Now, once they start pushing the box, there's going to be a force because of the friction. So the friction will push against it. Also, I think friction occurs because of intermolecular forces, but I could be wrong. So let's say this guy's pushing with the force, not N, we'll just do net force. It's not net force either. We'll say force man. So this man is exerting a force here. But the friction force is exerting a force back. And we'll say force F for force friction, or FF. And what will happen is, until the man can overpower the full force of the friction will keep applying. But once you overpower that friction force, that's when we get to kinetic friction. So a force friction is kind of like think of it like a speedometer. Like there's a max, which is, let's say it's 100 miles per hour. Well, until you're pressing on the gas pedal, it will slightly reach up to 100 miles per hour. The same way the friction force will only apply more and more force depending on how much force someone else is exerting to the opposite side. So in other terms, the friction force, or the static force here, won't actually apply until someone overpowers it, keeps pushing, where the friction force is forced to become a stronger force. Let me think of a better way to explain it. Yeah, that is like the most in-depth way I could explain it. Let's read what I wrote here. It adjusts up to a max. Imagine you're pushing a box on a surface. Once it starts moving is when your force overpowers the friction forces and gets to kinetic friction. So the Fs max is simply the max friction force that it is applying until it starts moving. So in other words, this is the amount of force that the object is pushing back on the man. But remember, the net force is just going to be Fman plus FF, and FF is technically negative since it's going in the left direction. So I guess you could write it as Fman minus FF. And once the man overpowers the friction force, so let's say this is 2 and 1, that means we're pushing with the 1 Newton of force. So simply put, this formula is just saying that, or this inequality here is just saying that you must reach the max before it starts moving, and friction will continue to be applied. So friction is not like a one static force. Um, Friction will continue to be applied depending on how much force you apply. So if I applied 0.5 newtons of force, technically we're not going to be at a -1 or negative -0.5 newton force because friction only acts when someone is pushing it. So technically, um, technically, even though this maximum force friction here is 1 newton, it won't start pushing back the box because static friction only applies when a force is applied to it. So technically it will be 0 newtons, 0 net force, because this doesn't actually push back. It only resists. It's a resistor. Think of like a hard button. It will resist force depending on like how hard you push it. Maybe it might go halfway. But once you overpower it and press the button in fully, that's when you fully overpowered the force and have pressed the button. Same thing here. The force of the man must overpower the maximum force of, or the minimum force of the friction. No, the maximum force of the friction. But friction builds up, and it's not just one constant net force. Is kind of logic here. That was like the best way I could explain it. And again, this is just a friction constant. So coefficient of static friction, and that depends on the material. I'm guessing because of intermolecular forces. Like ice is kind of slippery, so it has less friction than something else. But all it is mu s, which we don't know what this is. I literally have no idea of any friction coefficients. Like I know a lot of constants, but none of friction coefficients, and then just the net force, I believe, or normal force. Same thing. So friction, kinetic friction is the same exact thing, but that's once you've overpowered it. So if we go back to the man pushing the box, once they've overpowered the max, force friction can apply back. That's when we apply the static friction. It's the same exact formula, mu k, or the coefficient of static friction, times normal force. So key points, both friction scale with normal force. They're independent of the contact area, meaning that regardless of if the box is bigger or smaller, the scale or the coefficient of static friction will be the same. Friction is a parallel force, meaning that like if I'm pushing this way with, remember that I'm pushing this way with the F man, but the box is getting pushed back with FF. So there are two forces that act in the opposite direction, and these are considered parallel. Normal force is perpendicular push from surface. So that's all for today.